Very good afternoon, dear student. Am I audible? I hope I am audible. Uh, so let us begin new unit today, unit number 3, which is corrosion of metal, and we will be having question on this unit, which will be of around 11 marks. So pretty interesting unit. It has been related to our day-to-day life. In fact, all the 3 units which we have, all the 2 units which we have done in the previous classes, is also been was also been related to our life only. So this is also very much important, interesting unit, and we'll be learning so much so here, and we'll understand why we have been going through the topic corrosion and its control, or you can say corrosion of metal. So it has been said it is better to control rather than to prevent corrosion, since it is impossible to eliminate corrosion. See, you cannot eliminate corrosion, right? You just can like prevent it. Neither you have the right to control it also, right? Okay, so what we are going to do here is we are going to try to control it to an extent, but we'll try to prevent it, you know? And because we cannot eliminate the process of corrosion. So in the first few units, I'll be talking about the basic chemistry of corrosion. In the first 2 3 lectures, we'll be talking about the basic concept of corrosion. So let's see what is there in the content of the whole unit. The introductory part, it is there. Then the basic concept of corrosion, which is very much important. The causes and the consequences of corrosion. And then we'll go with the electrochemical and galvanic series. Then the factor which have been influencing the rate of corrosion. That is basically the nature of the metal and the nature of the environment. Then we'll go with the chemical and the electrochemical corrosion, the difference, the mechanism of electrochemical corrosion, then the Pilling Bedworth rule. On this Pilling Bedworth rule, we have a numerical for 2 to 3 marks. So we'll be calculating the ratio, Pilling Bedworth ratio. Then we'll be going with the differential aeration theory of corrosion, right? Then we'll go with the different types of corrosion, especially pitting, intergranular, waterline, and galvanic corrosion. Stress corrosion is also there. So I'll be talking about stress corrosion as well. Then how we can do the prevention of corrosion. Okay. So design and material selection hai. And then cathodic protection. There are many, but we'll be keeping ourselves as we'll be sticking ourselves to the syllabus which has been provided to us by the university. So there are many ways by which we can do the prevention. We'll be focusing on design and material selection, then cathodic protection, which will be comprising of the galvanic protection and the impressed current protection. Fine. So this was just the topic which we will be doing in this chapter. Fine. So it seems to be very small, बहुत छोटा दिख रहा है, but it is actually not that small. So there is so you'll be studying actually the electrochemical, you can say chemistry, electrochemistry in this. Fine. Majority will be oxidation and reduction reactions here. So let's talk about the contents of today's lecture. So in first 2 to 3 lectures, I'll be talking about the basic concept of corrosion. So in today's lecture, I'll be just talking about the causes of corrosion, right? The consequences of corrosion and the effect of corrosion. So what are the effect and the consequences and causes of corrosion in today's lecture? And then we'll be moving towards the chemistry part in the next class. So further moving, let's see what is introduction to the introductory part. What is corrosion? Corrosion is nothing but the destruction of metal or alloy. So what is metal and what is alloy? Metal, you know what a metal, right? What is alloy? Alloy is nothing but mixture of two or more metal which has been mixed, or it is a homogeneous mixture of two or more metal in a specific ratio. So that forms an alloy. अब मेटल से अलॉय बनाया गया है, बिल्कुल सही है। अभी क्यों अलॉय बनाया गया है? क्योंकि मेटल बहुत जल्दी करोड हो जाता है, वेराज अलॉय भी करोड होता है, बट द करोजन ऑफ अलॉय बेसिकली टेक्स अ लॉन्गर पीरियड ऑफ टाइम। अगर अलॉय को प्रॉपरली ट्रीट नहीं किया गया, प्रॉपरली बनाया नहीं गया है, तब इसमें करोजन का रेट ज़्यादा होगा। अदरवाइज अगर आप रेट देखेंगे, रेट ऑफ करोजन इन मेटल एंड अलॉय, नो डाउट द रेट ऑफ करोजन इन मेटल विल बी मोर एज कंपेयर टू अलॉय। फाइन। corrosion ना हो इसलिए alloy came into existence. Okay, so corrosion, as I told you, it is nothing but the destruction of metal or alloy. Exception is always there in chemistry, that is gold and platinum. They do not undergo corrosion. So the corrosion is basically been you can say it is because of the chemical or the electrochemical reaction with its environment. So the metal is been reacting with the surrounding, and there is some reaction which will be taking place, and that is leading to corrosion. Or you can also define corrosion. It is the deterioration of material by the chemical interaction with their environments. So metal and environmental component, they react together, and a certain new product is being formed. That product is nothing but the product of corrosion. And here you see, because there is a destruction of metal or deterioration of metal, or the property is being lost, henceforth we have been using the word corrosion with the metal. Fine. So there is another definition which has been given here. That is, corrosion may be defined as the gradual eating away or disintegration or deterioration of a metal by chemical or electrochemical reaction with its environment. So there are many definition which has been given. Okay, so we can say that corrosion is actually nothing but a deterioration of metal or destruction of metal, and in that process, that is in the process of corrosion, we have been losing the solid metallic material through unwanted, or you can say unintentional, chemical or electrochemical reaction, or the which has been nothing but the attack of environment on the surface. Fine. So the corrosion term is sometimes been applied to the degradation of plastic, concrete, and even to the wood. But generally, it has been referred to metal. अभी when I use the word corrosion of plastic, तो ये नहीं समझेंगे आप. Corrosion of plastic मतलब nothing but the deterioration or the disintegration, or you can say the destruction of what, the plastic. तो इसका मतलब क्या, कलर फेड हो जा रहा है, प्लास्टिक ब्रेक होने लगा है, तो आई बी सेइंग कि खराब हो रहा है प्लास्टिक. तो नो डाउट करोजन इज हैपनिंग देयर. Concrete भी देखिए, as time passes the concrete automatically sheds off, or you can see small particles of sand or cement, they gradually they are losing the surface. So no doubt corrosion has been occurring there also. So we are losing, और यू कैन से डिसइंटीग्रेशन हो रहा है, और हम कह सकते हैं डिट्यूरिएशन हो रहा है. किसका? कंक्रीट का भी. लकड़ी भी सड़ने लगती है. जब सड़ने लगी लकड़ी, मतलब उसकी प्रॉपर्टी खत्म हो रही है, खराब हो रही है, या स्ट्रेंथ नहीं रहेगा वो मटेरियल में. Then we can use, no doubt we can say corrosion, but generally this word corrosion is referred nothing to but to metal. It is been referred to metal only. लेकिन सभी चीज का corrosion होता है, हर चीज खत्म होती है, हर चीज का डिस्ट्रक्शन होगा, हर चीज डिसइंटीग्रेट होगी. सबके लिए टर्म्स जो है वो अलग अलग दिए गए. क्लियर? नाउ, so as I have told you, corrosion basically involves chemical or electrochemical reaction, and the use of the term is restricted to the destruction of metal and alloy only, not to plastic. We will not be talking about the plastic, or will not be talking about the concrete or the wood, but we'll be talking only about metals. So physical or mechanical wearing away of a metal is not corrosion, but it is known as erosion. Please do not mix up the word corrosion with erosion. Both are two different words. So any physical or mechanical wearing, for example, if you do the continuous scratching of the metal surface with a metallic wire brush, so what you're eroding the metal. Huh? or the process is nothing but erosion, right? So corrosion is a different part of story, whereas erosion is a different terminology. Please don't mix up these two things. So if corrosion and erosion takes place together, the destruction of the metal takes place at a very faster rate. So the most popular example for corrosion you can think of is nothing but rusting of iron. आप आजू बाजू देखिए, आपको सबसे ज्यादा यही दिखाई देगा, एंड बारिश में तो सबसे ज्यादा दिखाई देता है. Let's talk about certain examples of corrosion. So when copper is being exposed to the industrial environment, it forms an adherent protective green deposit which isolates the metal from the environment, hence the further action is very slow. देखिए करोजन हर मेटल का होगा, बट हर मेटल का जो रेट है, इंटेंसिटी है, वो अलग अलग होगा डिपेंडिंग अपॉन दी इट्स पोजीशन इन इलेक्ट्रोकेमिकल सीरीज, वो भी हम बाद में बात करेंगे. तो यहाँ पर क्या बता रहे हैं कि कॉपर जो है वो करोड तो हो रहा है, अभी जो करोड हुआ है उसने क्या बनाया है, एक बहुत ही अडेरेंट प्रोटेक्टिव ग्रीन डिपॉजिट, जिसको हम कॉपर कार्बोनेट भी बोलते हैं. और वो क्या करेगा, मेटल को आइसोलेट करेगा, मतलब फर्दर करोजन जो है, आगे आने वाला करोजन या तो मिनिमाइज हो जाएगा या तो बहुत स्लो डाउन हो जाएगा, बट करोजन होगा. अगर हम वो मेटल की लेयर, जो ग्रीन कलर की प्रोटेक्टिव लेयर है, उसको अगर हम स्क्रैप ऑफ कर देते हैं या हटा देते हैं, तो metal is been exposed to the environment again, and again it will react with the environmental component, and the metal will undergo corrosion process, or it will again form more adherent protective green deposit. Clear? So when we talk about iron metal, which has been exposed to the industrial environment, it forms a loosely as a adherent product. देखिए यहाँ दो चीजें बन रही हैं, एक हार्ड है प्रोटेक्टिव कोटिंग है, और एक है लूजली अडेरेंट प्रोडक्ट, विच इज नथिंग बट film of hydrated ferric oxide, and it has been termed as rust, which is relatively non-protecting. So copper metal जो था वो क्या हो जाएगा, बच जाएगा, लेकिन आयन मेटल जो था वो धीरे धीरे क्या होगा, करोड होता जाएगा, एंड वन फाइन डे इट विल ब्रेक, और यू विल सी the thickness of the rod or the surface of the metal is like it has been reduced, and you can see nothing but small holes there, or the metal is been it is vanished into the environment. Okay, so example देख लेते हैं Fe का. Fe reacts with water and oxygen, no doubt, and it forms FeOH thrice, and on further oxidation, actually +2 बनता है पहले, FeOH2, उसका ऑक्सीडेशन होता जाएगा, +3 बनेगा, उसका और ऑक्सीडेशन होता जाएगा, तो यू विल सी द फॉर्मेशन ऑफ Fe2O3XH2O. दिस इज नथिंग बट द फॉर्मूला फॉर द रस्ट, है ना. ठीक है, तो रस्टिंग इज अ डिफरेंट थिंग एंड करोजन इज अ डिफरेंट थिंग. सारे मेटल का करोजन होता है, बट रस्टिंग सिर्फ आयन का होता है, ये आपने याद रखना है. So you can see here rusting of iron. So we need both the things here, water as well as the air, and that increases the rate of rusting. When we talk about copper corrosion, so जो ग्रीन कोटिंग रहती है कॉपर पे, उसको हम पचीना बोलते हैं, which is nothing but carbonate of copper, that is copper carbonate, and it is formed because of the very slow chemical reaction which has been involving in copper metal, and it reacts basically with the carbon dioxide present in the atmosphere along with water. So for corrosion we require both water as well as एयर. ठीक है, एयर, दोनों, एयर में दोनों चीजें होती हैं, ऑक्सीजन भी होगा एंड कार्बन डाइऑक्साइड भी होगा. This is one of the, yeah, you can say, we can talk about the this theory part with the help of this equation. So you see nothing but CuCO3, which is a precipitate, and it is protective in nature. So स्टैच्यू ऑफ लिबर्टी आपने देखा होगा, शुरू में ये रेडिश ब्राउन कलर का था, लेकिन समय के साथ साथ क्या हो रहा है, अभी ये ग्रीन कलर का दिखाई देता है. तो ग्रीन कलर का इसलिए दिखाई दे रहा है बिकॉज ऑफ कॉपर कार्बोनेट, है ना. एंड अभी तक इसका करोजन रुका हुआ है बिकॉज प्रोटेक्टिव कोटिंग बनी हुई है. So ऐसा बोला जाता है कि the amount of money which is being spent on controlling corrosion is मोर देन 100 करोड़ अभी तो, बिकॉज इंडस्ट्री डेवलपमेंट हो रहा है, तो इट इज़ मोर देन 100 करोड़ इन इंडिया एवरी ईयर। एंड इंडिया में तो ट्रॉपिकल क्लाइमेट है, तो करोजन प्रॉब्लम इज मोर सीरियस देन इन कोल्ड कंट्रीज। ठीक है। सो द मेटल विच इज बीन वाइडली यूज्ड एज अ स्ट्रक्चरल मटेरियल are being corroded rapidly due to increasingly pollution of water and air. So pollution is one of the major causes for increasing the rate of corrosion, right? So now let us talk about the causes of corrosion, क्या क्या हो सकते हैं। सो पहला है कि इट इज जनरली easier to understand why corrosion occurs than how it occurs. ओके। सो मोस्ट मेटल, ये तो हमको पता ही है कि मेटल जो है ना, वो सारे के सारे दे एग्जिस्ट इन नेचर, इन नेचर इन द फॉर्म ऑफ मिनरल्स। ओके, राइट। ठीक है, फाइन। सो देर आर सर्टेन मेटल्स, एक्सेप्शंस हैं उसके, जैसे फॉर एग्जांपल सिल्वर, गोल्ड एंड, सॉरी नॉट सिल्वर, हाँ, gold and platinum. Yeah, these are basically none but the noble metals. So the most of the metals, they basically exist in nature in combined form, right? So they are basically in the form of their either oxides, carbonates, then sometimes sulfides, sulfates, chlorides, silicates, then hydroxycarbonates also. Fine. So they basically exhibit thermodynamically stable state because they are stable in nature, because they are present in the form of their salts. Okay. So the metal they have been now, which has been there in the nature, they have been extracted from the ores after expending, like investing lot of energy. बराबर है ना। बोलने का मतलब क्या हुआ कि दिस वाज द ओर। आपको पता है ना ओर एंड मिनरल में क्या फर्क है। सी वी ओर एंड मिनरल, राइट। सो वी हैव ओर, सो वी आर कन्वर्टिंग द ओर इनटू मेटल, राइट। तो व्हेन आई यूज द वर्ड ओर, इट इज इम्प्योर। ठीक है, ये क्या रहेगा, ये इम्प्योर रहेगा। बट मेटल जो रहेगा एक्सट्रैक्शन के बाद वो क्या हो जाएगा, प्योर हो जाएगा। अग्रीड, यस, राइट। अब ये और इम्प्योर है, लेकिन यहाँ पर अगर आप देखेंगे तो दिस इज बेसिकली नथिंग बट स्टेबल। और इज स्टेबल, वाई? बिकॉज ये हमको नेचर में दिख रहा है, इट एग्जिस्ट इन नेचर। अब किसी भी कंपाउंड के फॉर्म में दिखाई देगा तो नेचर में है, मतलब ये स्टेबल है। जब हम मेटल को निकालते हैं हम प्योर फॉर्म में विद द हेल्प ऑफ द प्रोसेस नोन एज मेटलर्जी। अब जब मेटलर्जी हम करते हैं तो वहाँ हमको बहुत ज़्यादा क्या करना पड़ता है, एनर्जी का एक्सपेंडिचर होगा। फाइन। सो यू गेट मेटल, दिस मेटल इज प्योर इन स्टेट बट दिस इज अनस्टेबल। क्या है ये, दिस इज अनस्टेबल, राइट। Since it is unstable, henceforth, because of its instability, it wanted to acquire stability. Hence, it reacts with the environmental component and it forms either any stable complex or compound, and then it becomes thermodynamically stable again. तो यहाँ thermodynamically stable था, यहाँ unstable हुआ, इसका फिर से क्या हो जाएगा, corrosion होगा, right? अब करोजन जब हुआ तो ये फिर से वापस यही वाली स्टेट में आ गया। यस, आई होप दिस इज क्लियर। सो this is what is being stated here, which I have explained you. Unless the nature of the metal is substantially changed, that is by alloying, the metal will have a natural tendency to revert back to its natural thermodynamically stable state. This is the basic reason for metallic corrosion. So, however, metal that exist in elemental state in nature, example gold, naturally have excellent corrosion resistance in natural environment. So, ये मैं आपको बताना चाह रही थी कि और जो था थर्मोडायनेमिकली स्टेबल था, विच वाज यू कैन से इम्प्योर, उसको हमने कन्वर्ट किया मेटल में, जो कि थर्मोडायनेमिकली अनस्टेबल हो गया है बाय द प्रोसेस ऑफ मेटलर्जी। अभी क्योंकि ये अनस्टेबल है, ये स्टेबिलिटी एक्वायर करना चाहेगा, इसलिए यहाँ पर क्या हो रहा है, ये हवा पानी जो एनवायरमेंट में उसके साथ रिएक्ट करेगा। You see from nothing but the process of corrosion, and you see corrosion product which is thermodynamically stable. So ultimately क्या हुआ, जहाँ से आए थे हम वहीं वापस चले गए। Why? Because every component in this universe wanted to attain stability, either by gaining energy or by losing energy. So here what is being done, the metal was unstable, it wanted to acquire stability, hence it reacted with the atmospheric component, and you see the formation of corrosion product which is stable in nature. ठीक है, समझ में आया? सो हायर एनर्जी स्टेट से लोअर एनर्जी स्टेट, लोअर एनर्जी से हायर में आया, हायर से वापस लोअर एनर्जी स्टेट में आ गया. Fine. Now let's talk about the consequences of corrosion. So there are many consequences of corrosion, and there are many effects also, and this may become very much, you can say, problematic for the operation and for the equipment. Then simple loss of mass of metal. So consequences में एक सबसे है कि failures of various kinds and the need for expensive replacement may occur even though the amount of metal destroyed is quite small. तो थोड़ा सा corrosion होगा लेकिन consequences बहुत ज़्यादा हो सकते हैं. अभी harmful effects देखते हैं. सबसे बड़ा harmful effect क्या है कि reduction of metal thickness, which leads to the loss of mechanical strength and structural failure or breakdown. When the metal is lost in localized zone, so as to give a crack line structure, so which is going to make the metal weak, and no doubt a small amount of metal will be lost there, but that will create a great impact onto the working of the machine. ठीक है, तो थिकनेस जरा सी भी कम होगी तो बहुत ज्यादा एफिशिएंसी पे फर्क पड़ता है. Then no doubt you will see the hazards or the injuries to people arising from the structural failure or breakdown, for example bridges, cars and aircraft. Then loss of time and availability of profit making industrial equipment. ठीक है, अगर corrosion होगा तो time loss होगा तो profit कम होगा, and बहुत ज़्यादा problems आएंगे. Then it reduces the value of good due to deterioration of appearance. Corroded material आप खरीदना पसंद नहीं करोगे, corroded bike या car खरीदना पसंद नहीं करोगे, so automatically उसकी values जो रहती है ना वो खत्म हो जाती है. No doubt aesthetically भी appealing नहीं रहता है. Contamination of fluid in vessels and pipes, for example, beer goes cloudily when small quantity of heavy metals have been released by corrosion. So this is for food industries. जरा सा भी contamination रहेगा तो it will be harmful. Fine. Then maybe there may be some mechanical damages to the valve and to the pumps, etc., and that may result in the blockage of the pipe, and explosion भी हो सकता है. ठीक है. Then perforation of vessel मतलब small holes हो सकते हैं, and the content may escape into the environment and it may harm the environment as well. So usually ये कहाँ पर देखते हैं कि carpet and all जो रहती है ना, if we see any area where you see leakage, so the carpets and the decoration is basically being spoiled because of the leakages and all. So there are certain areas like the boilers and all. So if we use the corrosive sea water and if it enters the boiler, so it may result in severe corrosion and it may result in perforation of the tubes. So no doubt because of the corrosion there will be loss of technically important surface properties of a metallic component. Okay, fine. So these could include frictional and bearing properties. Okay, then electrical conductivity, and then surface reflectivity or heat transfer across a surface. Or it may result into the plant shutdown, may result in the loss of product, may result in the loss of efficiency, and no doubt it results into the contamination of the harmful product into the main product, and at the end we can think of nothing but nuclear hazards. क्योंकि जितने भी आपके न्यूक्लियर पावर प्लांट है वो मेटल के ही बने रहेंगे, वहाँ ज़रा सा भी करोजन होगा तो न्यूक्लियर हजार्ड अगर हो गया, so it will be very much harmful for the environment and to the human population as well. So corrosion अच्छी चीज़ नहीं है, इसको हम क्या कर सकते हैं, एलिमिनेट नहीं कर सकते, but let us try to prevent it. प्रिवेंट भी करने की कोशिश नहीं कर सकते, हमको कंट्रोल ही करना पड़ेगा किसी ना किसी तरह से, बिकॉज मेटल इज यू नो कि यू आर नॉट गोइंग टू गेट द मेटल बैक. सो मेटल इज नॉन रिन्यूएबल सोर्स ऑफ एनर्जी. सो एक बार मेटल खत्म हो गया तो यू विल नॉट गेट इट बैक, यू कैन नॉट प्रोड्यूस मेटल. So we need to protect it as much as we can, right? So for today's lecture, I'm stopping here. Thank you. See you again in the next lecture. Kindly give your attendance.